As David mentioned, my name is Ali. I'm a solutions architect from Databricks. In my career, I was mostly focused in data science. I did some data engineering as well, and finally started doing machine learning engineering. Then I joined Databricks as a solutions architect. And today we're going to be covering some topics around ML ops, as David mentioned. So how we do data science and machine learning on Databricks side. What does it mean for us to go to production, and how we manage everything that comes with it. So as Dave mentioned, brief introduction about the company. Company was founded in 2013 by 6 founders who were from the Berkeley University. They initially joined a Netflix challenge that had to do with recommender systems. During that time, they developed Spark, and they almost won the challenge, but they were late by submission. And they decided to turn Spark into a managed Spark company where they open source Spark, but they started offering services for managed Spark, and the company slowly grew more than that. So today we focus on data engineering as well as data science and business analytics as well. So that's a little bit about the company. And as I said, today we're going to be talking about machine learning and data science at Databricks. So to begin the conversation, let's talk about data science and machine learning as a priority for the companies around the world and how this picture is looking like. So it is believed that the total market for data science and machine learning in 2022 is around $4 trillion. 83% of the CEOs say that AI has becoming a priority for them. But we do see a problem, which is 87% of the companies, and this is a big percentage, are failing to take their data science models to production. And the question is why, right? And I think it all starts with the thinking around machine learning and data science. So as a junior data scientist, if you were to ask me, what's the most important thing about data science and machine learning in a company who's looking to put the models into production, right? I would have told you, obviously, it's model selection or maybe feature engineering, which are a part of machine learning operations, but they're only a part of machine learning operations. And the full operation, the full life cycle that you have to manage is much wider and bigger than that. And that is why 87% of the companies are having a problem taking the models to production. And I want to start the slide presentation with a story that I personally experienced, and this was my introduction to machine learning ops. Before in my career, there was a time where we were tasked with creating a new machine learning model, which was supposed to forecast sales and predict the life cycle of certain products that were going to go to market. So let's say you're a manufacturer of a phone and you want to put this phone to the market. You want to predict how long this phone is going to stay in the market, at what point its sales are going to start going up, at what point its sales are starting going down, and how much sales you're going to get out of that. So we were tasked with this problem statement, and we had to create a model that was going to be able to do all of this, right? I was the machine learning engineer who was supposed to build the framework around this model and making sure that, we can take the model from development to production. And I was working with a couple of data scientists, a few of them, I think it was 2 or 3 of them, and some data engineers and some DevOps guys as well. So we were able to develop the model with ease. It wasn't too hard. Maybe, accuracy wise, of course, it could have been better and everything, but nevertheless, it was doing the job. And the next task was to take this model to production. At that point, things started getting a bit complicated for us because we started seeing some issues where data scientists were developing a model, they were labeling it as the production model, and we were going to try to take that to production. It had to work with certain data requirements, so it was expecting certain data sets to be fed in certain ways. And it was outputting the results in certain ways, and its performance was measured with different metrics as well, right? So the first thing that we started having a problem with was the versioning of the models. We put a model into production. It is somewhat working. DevOps guys is trying to retrieve files from somewhere, pickle files here and there. But next up, data scientists, they develop a new version. But we have to test this version. So how do we exactly build a staging environment that can retrieve the data and maybe get tried with the different environments? And it started becoming a hard thing because keeping a track of the versions of the models and their accuracies, and for example, the features that they were using, we didn't have a full process around it. So we were trying to do it manually by writing it in CSVs and trying to keep up it in that way. Things started getting harder when we tried to promote models to production and archive the existing production model. And things actually started breaking because whenever we did a promotion, the existing model, sometimes the data that it would be expecting would change, but the DevOps team wouldn't know about that. So it would start breaking and testing would become hard. And also sometimes the output that it was coming up with, it was changing. So, the parsing that had to do with the results was changing as well. And this problem became even harder and harder as we developed newer models that changed slightly because everything was changing and we couldn't keep a track of it. At the end of the day, this whole process became so hard that the management decided to let go of this model. And they said, okay, maybe it's going to do some value for us, but right now we're spending too much efforts on it. So we're going to shelf it for now until we can have a better way of doing it. This is why 87% of the companies are actually failing. So it's not model selection, it's not the data, it's not the DevOps part, but it's the combination of it and how you manage it is actually the problem. How do we combat this, right? What tools we offer from Databricks side, and how do we break this problem into small segments? In Databricks side, this is what more or less our offering looks like, which is an end-to-end product for your machine learning cycle. So for us, everything starts with data prep and versioning. Then we move into feature generation. After that, we go into model training, tuning, and so on with hyperparameter optimizations. And finally, we have some tools for easing the going to production side, when it comes to batch scoring, online serving, and monitoring as well. The primary framework that we use to enable all of these is MLflow. And MLflow is a technology that we developed in-house, but as you might have guessed, we open sourced it. So if you want to use MLflow on your own, you don't have to have Databricks, you can use it. But we offer a managed MLflow, and it comes with some benefits as well, such as increased security and an integrated platform for it. That is the backbone of our ML offering, MLflow essentially. And we also use this with our data layer technology, Delta Lake. This might be something that you might have heard of before, but it's essentially our way of taking on the data lake to have some really nice properties over there for the data layer solutions. So let's talk about our platform foundations and what our platform looks like a little bit. First of all, the nice thing about our platform is it can work on any cloud. So if you're working on Azure, if you're working on GCP, if you're working on AWS, we exist across all of those clouds. Some of our features, especially some of the newer features, might be missing in some of the clouds, but nonetheless, the primary ones and the fundamentals ones exist across all of them without any problems. And the nice thing is, since we offer a multi-cloud solution, you have the chance to, for example, set up a workspace on AWS, but read some data from a GCP bucket or an Azure bucket, or, for example, read some data from GCP BigQuery or Azure Synapse in that sense. Next up, what can you expect when you spin up the platform and you start having a look at it? This is something that the data scientists will most likely be familiar with, but our platform is based on a notebook-like environment. We have our own notebooks, which are a little bit beefed up compared to the regular IPython notebooks, and it offers some plus features on top of that. But I think one of the coolest things that it can do for you is the fact that it can work in multi-language. So, as a data scientist, your favorite data transformation tool might be Python. So you can start a notebook in Python, and maybe you're going to get to build your models in Python as well. But for example, maybe you have an easier time writing an aggregation query in SQL. So just by using a percentage sign and typing SQL, as you can see on the screen, you can switch a Python notebook into SQL and do some queries over there. For the results of the queries, with a few clicks, you can generate graphs. So it makes visualization really easy. And it's really ideal for exploration in that sense. And moving on, if you wanted to use Scala for maybe some of your big data engineering things where you're going to create a very optimized Scala UDF to be used with Spark, then you can also switch to Scala. And when you're done, you can always come back to Python or even R and go from there to build your models. As I said, it's ideal for exploratory analysis. So I wanted to show you a couple of things that you can do on the notebooks. We have native data profiling tools. So for example, if you queried a certain data frame, and this could be a pandas data frame, this could be a Spark data frame, with a single click, you can create a data profile for it, which can give you the statistical properties of the data frame, such as the mean, standard deviation, how many zeros does a certain column have, and so on. And this applies to all of the features, so both your numerical, categorical, and maybe text-based features as well. And visualizations on the left-hand side and generating them are quite straightforward. This is actually one of the favorite things that I like, whenever I'm building my own models. So it's really easy to generate visualizations in that sense. Talking about the data foundation and the Delta Lake, you might have heard of the Delta Lake before. Some solutions architects from Databricks side, they actually take on the Delta Lake as a Parquet ++ format. But essentially what it is it's a file format that you can save on your data lake. So on your ADLS, on your GCS, on your S3, it basically lives on there. Essentially makes storage costs quite low and minimal since it's living on the data lake. But the nice thing is it can work with any data that you have. So tabular data, text data, images, unstructured, structured, semi-structured data, what have you, as well as streaming and batch data. It can work with all of them. And it can give you some really nice features that you can use in machine learning as well, such as data versioning, which is something that we're going to speak about in a little bit. But I just wanted to cover what sort of a data solution we offer from Databricks. Coming to our compute foundation, this is also one of my favorite parts. As you might imagine, there are lots of favorite parts that I have about this product, but this is one of them definitely. Our compute foundation. So as a data scientist, while I was trying to build my models in my career, what I found is most of my time is spent on two things, which has nothing to do with model development. The first part is data cleaning, making sure I'm retrieving the right data sets, making sure that they are cleaned and filtered in the proper ways, no nulls or no unexpected things. That's where most of my time was being spent from time to time. And the other thing was making sure that my environment was configured right. So I want to build a certain model and I want to have scikit-learn and maybe NumPy installed in my environment. But sometimes these libraries start clashing with each other. And this problem becomes a harder one, especially when you start doing more complex stuff. So for example, if you want to run TensorFlow on your GPUs, and if you have to configure the CUDA cores for it to make sure everything is working properly, we all know that sometimes that can be a painful process. We, from Databricks, we saw this and we started offering a compute for this to solve this problem exactly. So whenever you spin up a cluster on the Databricks platform, it comes with a ready environment installed for you. And this environment, it has most of the things that a data scientist can need, right? Maybe you're going to need scikit-learn. Maybe you're going to need maybe you're going to need Keras. Maybe you're going to need TensorFlow, like GBM as the models. All of them are installed over there. You need Spark, Pandas, NumPy for your data transformations. They're also installed, as well as some other libraries that we have, such as HyperOpt, which can give you the necessary tools to distribute your training and hyperparameter optimization across a cluster. So it's a time-saving tool. And the nice thing is you can take this runtime. And for example, if you have a specific library requirement, which is not installed on it, you can install on it. Or if you have custom libraries that you have developed in-house, you can also choose to install them through various ways. So it's a time saver in that end. It makes things very easy and it is configurable too. And finally, the biggest part of the talk, our MLOps foundation. So we took a look at this picture as well, and we tried to identify the different stages where we needed to build a product for. And we realized that, everything starts with an ML environment, which is the part that we have just covered with our compute instances. Then we move into data preparation and feature generation. For that, we offer a feature store, which is something that we have developed recently. It's going to become generally available very soon, but it is essentially a really nice and neat way of building a feature library that can be used for multiple use cases. Then we move on to experiment tracking reproducibility part. which has to do with, building up your models, training your models, understanding how your models are being affected by certain hyperparameters, how they change as you change your features, and keeping a track of all of these. Everything that you need to keep a track of when you're training a certain model. From there on, we move on to model lifecycle management. This is the part where you start, moving your models, the ones that you have trained and experimented on, into production-like environments like staging and production. So, having that similar to Git flow, having that flow over there where you're like promoting models, testing them out, and then slowly moving them to production. That is something that we cover with MLflow as well. From there on, we move on to the next stage, which has to do with model serving. We offer multiple ways of doing model serving depending on your requirements. So if you're going to use your models in batch, we have some tools for that. If you're going to use your models in a streamed way, you can definitely do it with the power of PySpark and everything else. And also real-time model serving, that is something that we have covered as well. Finally, I believe this is one of the newer parts of our ML offering, which has to do with model monitoring. So whenever we were implementing this whole framework with our clients, the final question that they always asked us was, okay, everything seems to be working. We can move our models properly. We can train them. We can use this. We can do that. The registry for model lifecycle management is working properly as well. But do you have some capabilities which we can use to monitor our models in production? We want to understand how they're doing. And if their performance starts degrading, then we want to trigger some retraining on top of that. So this was a question that we kept getting asked. So saying like, what sort of capabilities do you have for model monitoring? And in the end, we decided to develop some capabilities for that too, which is something that we're going to cover in a little bit too. But essentially, looking at this, we have the full ML lifecycle covered from top to top. From bottom to top, and then we use MLflow to cover each bits and pieces over here, as we have mentioned. All right, so let's talk about the feature store. The beginning part of our pipeline that we see here after the ML environment. So what is the feature store? When you think about it, I think the first thing that might come into your mind is some sort of like a feature library, which is exactly what it is in terms of some parts, right? So let's imagine a real life scenario where I am a data scientist and I'm working on a certain data set. This data set is going to be, let's say that this data set is going to be worked across multiple data scientists, and we're all trying to build a certain model out of it, or maybe multiple models out of it. What we do as data scientists, of course, we do the EDA parts where we do explore the data, do some analysis on it, try to understand what the columns and everything else is looking like. The next part, which is, I believe, like some of the practitioners in the ML world, including Andrew NG, they would argue as the most important part in machine learning, is the feature generation bits. So generating features, trying to make some sense out of the data, adding your domain knowledge on top of that data, and coming up with something that explains the problem better to the models, right? So that's what feature engineering is about. And to be able to do this properly, we came up with this feature store idea, which is not the first, obviously, as far as the feature stores goes, but it's our take on it. And essentially, what it is a sort of like a data layer solution, which you can use to save the features that you are creating. So how does it help you? How does this help your team? Chances are, if you're working on a data set, the next day some other data scientist is going to work on the same data set, right? So there shouldn't be any need for them to discover America again. If you have created a certain feature, and let's say that this feature has to do with houses, or the way that you measure something in a house, and you created this feature, you saved it, or maybe it has to do with a certain product, right? Maybe you're trying to understand the life cycle or the lifetime value of a product, and you have a certain formula for calculating it. You can basically take that formula, turn it into a function, and save it as a feature in the feature store. And the next day, when your colleague comes in, and whenever they need the same feature to get like the product life value or something like that, they can just start using that feature. What this helps with is, first of all, it makes it so that product life value has a single formula across all of your data scientists. Because otherwise, product life value might be a different thing for me, and product life value might be a different thing for my colleague, and we might end up calculating something wrong. So in that sense, it acts as a feature library, and it helps with the discovery of features, saving some time and boosting collaboration over there. As well as it is something that you can use while you're going to production as well. So let's say that there is a certain way of you generating your features on a data set. So in a data set that you're using for training, you're using that data set for generating your features, and you have built up some functions for it. You want to basically replicate the same process in production as well, just to make sure that your features are coming in the same way. So in that regard, the Feature Store can also help you as well. So it's a neat little feature that we have that can help you greatly when it comes to the feature engineering bits. Next up, the ML flow lifecycle, and this is again one of my favorite parts. So we're gonna be here for a while. And I really want to explain this in detail because I think it's quite extraordinary the way that the model lifecycle has thought out, and the way that it helps build certain machine learning models at production grade, right? So the way that ML flow takes care of all of the problems for us that we were talking about, which has to do with tracking your models, keeping your metrics in line, making sure that you have all the data that is related to a certain model, and then finally moving that model to staging and production and going to production with it, right? So that is like the core concept of ML flow, tracking your models. Everything in this sense starts with ML flow's native integration with the existing machine learning libraries. ML flow has a native integration with scikit-learn. It has a native integration with TensorFlow, XGBoost, Keras, and all the other populars that you can think of as well, including PySpark's machine learning library. What that means is when you enable auto-logging on the Databricks side, which is just a line of code, and when you start training a simple model, right? Let's say you're going to try to train a linear model on the platform from scikit-learn. Whenever you train that model, MLflow understands that you are training a scikit-learn model. And since it has a native integration with the scikit-learn model, it can then go ahead and retrieve everything that is related to that model, right? It can check out which hyperparameters were used to train that model, even if you haven't configured anything, even if you're using the vanilla model. It can understand the metrics that you used to basically evaluate that model. It can understand where the artifacts for that model was saved in terms of like the pickle file that you generated with the model, which is essentially the model itself. And it can also understand the data that was used to build that model. And it can, if you wanted to, if you configure it in the right way, it can save a little snapshot of that data just so you can go ahead and check it out and say, okay, this is what the data frame looked like while I was training that model. On top of that, it also keeps a record of the code that you use to generate that model. So let's say that you had a certain notebook on Databricks and you use that notebook to generate that model. What it does is it saves the exact specific version of that notebook and it ties it to that model. So 2 weeks later, maybe you did some changes in the notebook, but you have to go back to this model and regenerate it for some reason. You can go to the model's page, and you can basically say, give me the notebook exactly as the way it was while I was generating this model. So it will give you the full code for it in that sense, in a versioned way. So it keeps a track of everything. The way that it keeps a track of everything is, this was like the micro scale of things. When we talk about the macro scale of things, MLflow has these things called experiments. So for example, as a data science lead, let's say you're going to work with a certain team, right? You have a team of 4 data scientists. You're taking on a new task, a new problem statement. You're going to predict stock prices or something like that. As a lead or as a manager, what you can do is you can create an experiment on MLflow, and you can go back to your team and say, look, team, I know we're taking on this task, and I have created this experiment for you. The experiment ID is this, and can you please use this while you're building your models? Whenever you share that and whenever your team starts adopting that experiment ID, what happens is every single run they do, every single experiment, every single model training, every single run that they do including the hyperparameter optimization runs, they get saved and tracked under that experiment. So, Joe did an experiment with a linear model. These were the hyperparameters. This is the data. This is the accuracy. And this is all the other things that are related to it. Next up, Ali did this thing with a SVM model, and this is what he got. Everything starts getting tracked over there, which gives you a holistic view on all of the training and the experimentation that you are doing. It keeps track of everything, right? So in a month's time, you might have trained maybe 1,000 models, and it gives you the necessary tools to be able to compare all of those models. And that is exactly what the experiment is for, right? It is for understanding how your models are progressing, how your accuracy and performance is increasing, and how your hyperparameters is affecting maybe all of this thing, right? Next up, maybe as the lead, what you might then do is identify a suitable model from that experiment. You have trained 1,000 models, and now you're happy with one of them. It is working as fast as you would like to. It's proving it has the nice accuracy and performance that you would like to see, and you're happy with that model, right? What you want to do next is you want to take that model into the next step, which is going into the registry part of things. So you can take that you can take that specific model in the experiment, and you can promote it to the model registry, saying that now I want to put this model into staging or into production. This is almost like having that Git flow where you have the master branch, where you have the staging branch, and where you have multiple develop branches. So your multiple develop branches would be your individual runs falling under your experiment, and then the staging and the production branches would be the ones that you would see on the model registry side of things. Over here, you can follow a Git-like flow again, where you request your models to be promoted to production. So you can make a request saying that, hey, you know what, I think this model is looking good. I think it's ready to go into production. We've done the necessary tests for it. So I'm going to request for it to be moved from staging to production. You can do this via code or via the UI, so it doesn't really matter. So you can incorporate it into your working however you like to do. And you can have a gatekeeper on the model registry side that is basically saying that, okay, this model is ready to go to production, or I want to see some changes that happen to this model before I can take it to production. So you can have that over thing and have that thing over there. And it's so nice because this basically helps you track the way that you want to go to production and manage the whole flow behind it. So what happens once you are set on the model that you want to take on production, or what happens like once you're set on the model that you want to have in staging, right? How do you take these models and how do you actually go to production? How are these models going to predict stuff in the production? How the data is going to come into it? As with everything, our platform is quite flexible when it comes to this. So we offer a couple of solutions for that. The first one being your do-it-yourself solution. So maybe you like building your own solutions in terms of serving. You're going to write your own Flask API code, and you're going to deploy some pods via Kubernetes on the GKE environment. So that is something that you can do. And your DevOps guys, they would really like MLflow if they tried it, because MLflow creates a queryable object that you can incorporate within your code. So your DevOps guys, they can do something in their code, such as please go ahead and get the production model from MLflow and all of the artifacts related to it, including something like the requirement.txt, including something like the pickle file that needs to be saved with it, and take this model and sort of deploy it in this way in my own Flask Kubernetes architecture. So your DevOps guys basically gets a queryable object from MLflow side, which is something we call the MLflow client, and they can use this to retrieve production or staging models as they wish through code or again through UI. So they can incorporate it into their work however they like to. On the other side of things, I think as of now, most of the models that do go to production, they actually are large-scale batch models. So they're not real-time models, but they get run like on a scheduled basis, maybe every day, maybe every week. The way that we sort of enable this is, again, using MLflow, you can create a custom PySpark UDF as a model, right? And you can take this PySpark UDF, it is a function, like a pandas function, and you can apply it on a certain data set. This could be your prediction data set where you have the necessary columns and you need to generate predictions on it. So by using the distributed processing power of Spark and the UDFs that you get with MLflow and Spark is, again, you can take that model and you can apply it as a transformation function on top of a data set. And this is something that can help you while you're doing your large scale batch training. The final part is the low latency online one. So maybe your model is going to need to serve a front end client, which is going to do predictions on the go. As a user clicks on something, maybe it's going to recommend some products and so on. So you can take your model, and you can also use the low latency online serving that we have. And this also integrates within some of the existing cloud services, such as Google's Vertex AI. With I think 4 or 5 lines of code, you can take a model that you have developed in the MLflow registry, and you can deploy it onto a solution like the Vertex AI. We also have some online or real-time serving capabilities on Databricks side. As of now, they are more geared towards production, so they can only handle 200 requests per second, which is definitely not production grade, especially if you're going into the big data, big data space. But using the MLflow framework on our platform, with just a couple of clicks, you can create an HTTPS link, which would be the online serving link for your model. So you can take this link and, for example, in development, if you need to share it with some front-end guys who are also developing some features with you, you can give that link straight to them without having to write any Flask code or anything. It's just a click. And you can tell them, and saying that this is where our staging model is living. So you can make REST requests to this one, and you can test it out in that way. So it proves to be a really nice development feature right now. You don't have to write any code, any Flask code or any API code. With just a single click, you can deploy your model to production in that, real time in that sense. And as you might have guessed, we're obviously working on ways to take this to production too. So we're working on the version 2 of the serving capability, which is going to give you, again, cloud agnostic serverless model serving capabilities, which is going to be production grade. And since this is going to be serverless, you're only going to be paying as much as you're making the request, because there won't be an active server that needs to be spun up all the time and ready waiting to be to answer the requests that are coming in. So this is something that we're working on, and I think we'll probably have it in 6 months of time, but please don't quote me on that. Final stage of the parts, which is, I think, one of the most important bits, when you're going to production, because you might have taken care of everything, but what is your strategy when it comes to retraining your models? So how do you know that the model is still sound, it's still working properly, and how can you tell that it needs retraining and so on? So that's where the data and model monitoring comes in. And these capabilities, which is something we're currently working on right now, it's in private preview. I haven't actually tested it myself yet, but I'm going to try it real soon. But these capabilities essentially give you the necessary tools to be able to test your models after you promote them to production and after you deploy them into production. It can help you answer some of the questions such as, is there a drift between scoring data and training data? Is there a drift in the input features over time? Is there a drift in the model outputs over time? How is my model doing? Or how does my model accuracy change over time? Is it still working, or has the data changed a little bit? So do I need to retrain my model? And some of the metrics that you can tie to it is some statistics such as the shape of inputs. So how the input data is changing, drift in training versus scoring. So is the data is changing? The delta in the nulls, delta in count, and multiple vectors such as that. And also quality metrics as well. So how is my classification metrics are changing? How is my regression metrics are changing? So it is going to give you the capabilities to be able to monitor all of those. Finally, to come to the part which, when I first heard about this, it was a bit scary, I'll admit that. Because, as a data scientist or a machine learning engineer or in the field, whenever you hear the auto part, you're like, it's going to take my job. It's not nice. I don't want to see that product, but nevertheless, I explored this AutoML and I understood how it works. And the good thing is it's not here to take our jobs. So, there's that. And the way it works is I think is quite intuitive, right? And it's really nice in that sense because it almost has a symbiotic relationship with a data scientist. And I will explain what that means. So you can use AutoML in a certain way, but let's talk about the tasks that we do whenever we take on a new data set, right? Let's say you've downloaded a new data set from Kaggle, you're going to take on a new challenge and you want to work that out. The first thing as a data scientist that you would do is to create an exploratory data analysis notebook for that data set. What are the columns looking like? What is my data looking like? Do I have missing values? What is the statistical properties of this data, and so on? So that's the first thing that you would do, and maybe generate some graphs to understand correlations and everything else with it. And the next thing that you would try to do is create a baseline model, which is then going to be something that you're going to use to compare whenever you're building the next model. I've spent 10 hours on this. I'm using a neural network, but how much of a marginal accuracy performance gain it is giving me as opposed to my baseline model. So that is always the question over there. Like, is it worth using this model? The nice thing about AutoML is it takes care of all of these steps for you. So it gives you a head start whenever you're starting a new project, right? You can take AutoML and you can give it a task as in something like, hey, AutoML, look, there's this new data set that I'm going to try to work with, and it has 10 columns, and it has the 11th column as my target variable. Maybe you have something like house features, and your 11th column is your house price, which is what you're trying to predict in terms of like given the house features, how much this house is going to cost in that sense, or what its value is. So you can define a problem statement as such with AutoML, and you can give it a constraint. You can say, AutoML, you have 1 hour to figure this out, right? So what AutoML does within that hour is, first of all, it creates an exploratory data analysis for you. So all of the analysis that you might have to do, I would say it probably covers 90% of it. Correlations, statistical properties, everything. It generates that notebook for you, first of all. And second of all, in the remaining time, it starts trying out different models on that data set, as well as feature engineering. So if it sees a text feature, it is going to use TF-IDF on that to convert it to a feature, right? If it sees some numerical features, maybe it's going to apply standard scaling on it. And same goes for categorical. Maybe it's going to go for a one-hot encoding in that sense, right? So it builds your features and it starts training models on top of those features. And at the end of the hour, it comes back to you and says, this is the exploratory data analysis notebook. These are the 100 models that I have trained for you. And this is the one that had the best accuracy. But it doesn't stop there. It also gives you all of the Python code that you might need to reproduce those models, as well as the exploratory data analysis. This is the part where it is symbiotic, right? And this is the part where it has a glass box approach, as opposed to some other solutions, which are, you don't know what's happening in the backgrounds. It gives you all of the Python code, so you can take that code and you can customize it however you like to do. So maybe, AutoML did some feature engineering and it tied a classification model on top of it, which is a random forest or something. And it gave you the code for that. But of a better way of doing feature engineering on a certain text field. Maybe you're going to use GenSim rather than, TF-IDF or something like that. So you can basically take that ready code and you can customize it and start building on top of it. So all of the similar boilerplate code that you would have to write to generate that baseline model is taken care for you. So it gives you a head start in that sense. At the moment, it is purely commendable through a UI, and you can also do it through code. So you can configure how you would like to run through code as well. And it can take on classification, regression, and time series forecasting problems for you. It can use scikit-learn, XGBoost, hyperopt, LightGBM, and Profit while doing these tasks. and it can work with numerical, categorical, and timestamp and text features as well. In the roadmap, I believe they are also going to include TensorFlow as a framework that you can use to train your models. But as of now, this is more or less what it can do, and we keep building on top of it. And it's a really nice feature that can help data scientists in multiple ways. That concludes my presentation for today. And I hope you enjoyed it, and I hope you have a better understanding of what our ML offering looks like, and some of the methodologies as well as the frameworks that we use to take models to production. And I think we're going to go into a Q&A session just now.
Amazing. Amazing. Absolutely love that, Ali. Thank you so much. Great session. We've got stacks of questions that have already come in, which is a great sign. And actually, Geraldo has already commented in the chat just to say amazing. So there's a good number of you out there. So if you have enjoyed that session, please do fire a little comment into the chat, a little virtual round of applause, some clapping emojis, something like that. So Ali, you're going to have to imagine that standing ovation as everyone's on their feet at the end of your session, mate. So we'll get a few of these coming in. I can see they're already coming into the chat, so I'll yell a few out, but you'll be able to see them coming in as well there, Ali. So just proof that there are hundreds of people out there watching you wherever they are in the world, man. So
yeah,
I'll do my best to get through a few of these for you. Actually, it's always nice to get that kudos, isn't it? So Emma, really enjoyed it. Thanks very much. Informative. Adeyemi, awesome. Robin, yes, great session. Ali. Miriam, clapping emojis. I'm a fan of the clapping emoji always. So Elizabeth, very interesting. Thank you. Jason, thank you so much for the great talk. Load more clapping emojis. We've got an awesome bravo with 6 or 7 exclamation marks, Ali. So again, that's always a good sign. So yeah, we've got loads more. I'll jump back to some of those as they're coming in. And yeah, head into some questions. So I'm going to do my best here, Ali, with the questions. There's 21 currently, so we'll see where we go with the time that we have. Just to mention to the people at home, you can upvote questions, so that'd actually be quite helpful for us to make sure we pick the ones that the people at home want answered first. So I will go to the top of the list there. Question from Ananda, talking about the Databricks in different environments, Ali. So hopefully you can help with this. As mentioned, you know, if you prefer to take anything offline or whatever, that's all good. But the question from Ananda, if using Databricks in AWS today and down the line you move across to GCP, how seamless is it to move between the cloud platforms?
So it depends on the migration that you want to follow, and I'm guessing there would be multiple things that you would have to migrate. The first thing would be your workspaces. So you know, all the notebooks that you have, all the code that you have created on the platform side. So that would be the first thing that you would need to migrate over there. And next up, you might need to migrate some of the artifacts that you have created, as well as like the data sets and the features that you have created. I'm not gonna lie, it won't be like a walk in the park in that sense, but we do have some tools that is like helping, you know, with automated migration. So you can run a certain script and it can help you, you know, take something from point A and put it on point B. But the nice thing is, even if you want to do that, you know, even if you want to take and start using a different cloud, that cloud will still be able to access your old cloud's storage layer. So, you know, if you have your data stored over there and maybe you're not just ready to move your stuff all the way, then it will still be able to attach to that and work with that, you know.
Amazing, amazing. Thank you very much for that one, man. Next question there, I mean, you did touch on retraining models and stuff like that. So if I do fire through any of these questions and you have already covered them, obviously just let me know and we'll skip past them. But again, another question that's had a lot of upvotes. How does MLOps Foundation enable retraining of models in case of data drift? So I know you did touch on that, but is there anything worth just recapping there?
Sure. So personally, I'm always a big fan of automation. I would automate everything if I could, you know. And in the same way, MLflow offers the necessary tools for you to be able to automate as well. The first thing, of course, that you would have to do is detect the model drift. So you would have to write the necessary code and define what model drift means for you in terms of like your metrics and accuracies. And once that does happen, once you have that problem statement, once actually model drift starts happening, you can if you wanted to automate everything, you could define webhooks through ML flow that can actually say that, a certain metric has fallen below a certain value, and this is the time to trigger a retraining. So it can create an automated job in the background that can go ahead and train a new model with the new data that you have.
Amazing, amazing. Thanks, Ali. Next question, mate, I'm conscious of time, so I'm just firing into these, Ali. So we'll do our best. So question there at the top from Lamia. If models are defined in the notebooks, how does one share code across notebooks to avoid repeating code blocks? For example, if one prefers to write functions for data transformations.
There are a couple of ways. First of all, a more production grade way of doing that is if you have concrete knowledge of which functions are going to be repeated, you can create a Python library out of that, and you can have different modules which then can be installed on your environment so that you can import those functions as like a custom library that you have built. Also, what you can do on Databricks side is you can create like a common functions notebook, and you can import that notebook into different notebooks. So maybe you have 10 common functions that you are using, and this is something that's going to be used across everyone. You can define that notebook, and just as the way that you would import a module, you can import that notebook into the notebook that you're using and use the functions.
Amazing. Thank you very much for that one. Question from Reese. Can ML Flow profile the summary statistics of training data and alert you if some features in the ingested data experience data drift?
It's not something that it can do natively. So ML Flow, it's not that smart yet, I would say, but it's obviously of course like it's something that you can define on ML Flow side, and you can put the necessary checks in place to make sure that if there is certain drift that you can detect it, but not in a native out of the box way.
Perfect. Thank you very much. Super quickly, I'm going to jump back into the chat because there was a good 50 messages there. So it's always nice to give people a few shout outs. So Ingrid, Gosha, Serkan, Lamia, Ananda, Peter, Tanmay, Sana, all saying very clear. Thank you. Bravo. Nice session, etc., etc. Camilla, great to see you online, Camilla. Katie Solomon, star emojis in the eyes as well, so yeah, it's landing really well, so that's all good.
Right.
I'm going to shoot down to the question there from Matt, if
Sure.
You're following along in the Q&A. Matt is asking, can the Databricks serving endpoints implement authentication? Yes,
they can.
Perfect, thank you. That is what we like to hear. I'm then going to fire down to Thomas. Can features stored in the feature store be shared across Databricks workspaces?
Nice question. Interesting. I think not exactly, I would say, but yeah, I would say you couldn't do that. Yeah, I think feature store would be specific to a certain workspace, so it would stay there in that specific workspace. Perfect.
Thanks, Ali. And then if I fire back up here a bit, the question at the very top from Jitendra, asking about ML flow and the differentiation between deep learning and NLP and machine learning, and obviously subsets and subcategories of machine learning or whatever. Is it only useful specifically for particular use cases, or can you use it for broadly across deep learning, NLP, different machine learning?
It's a very good question. I think it can be used for almost everything, because it has a customization part to it as well. Obviously, it natively integrates with most popular libraries like scikit-learn, so it can pick up on those models. But if you wanted to create your own model, which could be like a Python function, which could be something else, you can use the custom functions and the API in MLflow to track what you need to track, if it's like a hyperparameter that you have customly built, or like a specific metric that you are building that is custom built, again. So MLflow can also work with those, and it can also track with those. And this is something that I actually had to do recently when I was building a recommender system, because recommender systems, they're usually like more code than like a scikit-learn model, and it's custom built stuff. So you need to log specific hyperparameters for it, and also measure different types of accuracies and so on. So in that sense, it again proved to be a very useful tool.
Perfect. Thanks, Ali. That's super useful. Question there at the top. I mean, obviously, everyone's aware of Databricks, but people are perhaps seeing some of this stuff for the first time. So the question there at the top is talking about, is Databricks an IDE, or does Databricks integrate with other IDEs? How would you best describe that?
Yeah, this was like a question in my mind when I first joined the company, because I'm a big PyCharm guy, so I like my IDs a lot. I worked with like most of them in the past as well. So when I first opened up the platform, I was like, is it just notebooks? Like, where does it go? One thing I would say is notebooks. They caught my interest really fast, and now I actually prefer them over an IDE. But if you still want to build in an IDE, we offer integrations with those too. So you can integrate like PyCharm onto a Databricks platform, and like if you have a Spark job that is supposed to run, then it can run that on the Databricks cluster.
Perfect. Thank you very much. Thank you very much. I've shifted my view around on some of these questions. So I've actually gone down to most recent now. So I've fired down to the most recent question that's come in from Martin. Martin is saying, in terms of Git integration, is there a way to resolve Git conflicts without having to resolve on local machine /terminal?
Yes, exactly. So we have a repos functionality, which you can use to integrate your like Git repositories, and it is definitely the suggested way to do so, especially if you're thinking about going to production. It also enables sharing code across different workspaces as well. So maybe you're going to have a dev workspace, and maybe you're going to have like a production workspace. If you want to share the code across them, Git would be the right way of doing it. And we also have a native Git tool on the platform side, which can help you with pulling your code, pushing your code, and resolving conflicts and so on. So we do have the capabilities for that.
Perfect. Thank you very much. And it's a really good question actually just come in from Pratyush, and it's already had 4 upvotes. So they're asking, is there an example tutorial which we can follow to develop something end-to-end in Databricks, data model, manage, model drift, all that sort of stuff? So if people want to go away after this session, you've inspired them all, they want to continue learning, what are your recommendations?
I would recommend definitely trying it out. We have videos on YouTube. I'm a machine learning specialist on Databricks side, what they call an SME, and our SME lead actually has put a lot of videos into YouTube. So if you want to follow up on those, you can definitely do so. We also have what we call solution accelerators on our website. So if you're in the FSI sector, if you're in retail media, you don't have to start from scratch if you want to develop a certain model. If you need a collaborative filter for a recommender system, we have that, or something to predict stock prices. We've actually built like the some sort of like a template for it. So you can take those on, and you can start using them straight away. If you want to set up your own Databricks instance, I would say that the easiest setup would be through Azure, because we're a first-party service on Azure, so it would be really easy to set up. I would say it might take like 5 minutes for an experienced person, maybe half an hour to 1 hour for someone who has less experience on Azure. But using those solutions accelerators, spinning up a platform on Azure, it could be the way to go for you.
Amazing. Thank you very much. Thank you very much. I am conscious of time. We do try to keep these sessions that sort of 1 to 2 o'clock UK time. I know people will be joining from all over Europe and the wider world, but we do try to keep it. I know people will be busy with meetings and stuff. So I'm going to take a couple more questions, and then we'll wrap things up by saying thank you to Ali. So a couple of questions, again, mainly, if I'm honest, about features and, people, you've obviously sparked the interest in people wanting to go out there and test out Databricks. So it'd be good to just confirm a few things there. So first of all, question from Mohammed. All of the features that you've presented today, are they all available in Azure? It sounds like Azure is the go-to. Can you give us a bit more breakdown in terms of what's available on what cloud?
Yeah, sure. Let's actually go back to this part, which is showing the features that we have.
Ali, I'll just jump in, actually, maybe get you to share that screen if you've got
Oh,
a
sorry, I
slide.
stopped sharing. That's right. All right, so let's go for it. So left-hand side, clusters, ML timeline libraries, and Delta available on all clouds. Feature Store is a feature that we have just finished developing. It will be generally available across the clouds soon. I believe AWS and Azure is going to be first ones. GCP might come a little bit later. The core ML flow foundation, experiment tracking, model lifecycle management, registry, model serving, all of that is available across all of the clouds. So you can do it, especially obviously, if you're on GCP, then if you're going to go for real-time model serving, you might go for Vertex AI, versus if you're on Azure, then you might go for something like Azure Machine Learning or managed endpoints. So that would be that would depend on the cloud that you're using. Model monitoring is something that we are in the midst of developing. It's currently in private preview. So if you have a specific interest for it, you can let us know, and we can work with you if you want to onboard it to see how it is. But I believe it will be in GA in 1 or 2 quarters as well. So that's more or less where we are.
Perfect. I love that. Thank you so much.
Sure.
I will start to just wrap things up then. We've done really well there. It was ridiculous in terms of the number of questions. I think there was about 40 questions floating around, and we've got through roughly half of them. So I think that's a great effort so far. In terms of Databricks, as mentioned, they are partnering with us for the year. I appreciate, obviously, not everyone is in the UK, but if you are, they will be at the Data Science Festival in person in June. And again, they will be back with us later in the year at Data Science Festival online. So just drawing things to a close, I'm going to finish off with a few more comments from the chat. So I feel like you need to share this with your family, Ali. Let everyone know how popular you've been this lunchtime. But just firing through a few. Really amazing, Ali. Very nice presentation. Thank you. Thanks. Very interesting. You rocked, Ali. Thank you. Nice. Well worth knowing about. It's very exciting. Triple bam. That's probably my favorite so far. So thanks for that comment. Thank you so much. Great talk. Thank you. The list goes on and on and on. So there's stacks of people. So I'm going to wrap up by saying thank you for everyone at home for being with us and coming to share with the festival. And obviously finish by saying thank you to Databricks, and thank you primarily to you, Ali. I know it's not just a case of turn up and give a session. There's a lot of preparatory work and making sure the slide deck's all pulled together. So really appreciate it. And thank you very much for your time. So I'll give you the last word, Ali. How was it for you? Did you enjoy it?
It's great. I can talk about this for days. It's what I really like as well. So I want to thank everyone for joining as well, and thanks for your time as well.
Amazing. Thanks so much, Ali. Hope to see you soon. And thank you to everyone. And we'll wrap things up and say goodbye. So have a good one, everyone. Thanks and goodbye.
Bye.